This animated cross-section shows the ambient air over a pharmaceutical weighing station. What looks like clear air to the naked eye is actually filled with fine solid particles. Inhaling these invisible suspensions is what we call dust exposure. Each microscopic particle is a concentrated mix of active pharmaceutical ingredients, raw materials, and organic matter. These substances accumulate silently in the respiratory system, often causing significant damage before the body exhibits any outward symptoms. Treating dust control as a simple housekeeping task leaves the real danger unaddressed. Properly managing these particles is the absolute baseline for protecting both the purity of the product and the long-term health of the people making it. Take a look at this facility schematic, starting at the top left. The primary operational triggers for dust generation occur early in the production cycle. Raw material handling, along with processes like granulation and fluid bed drying, constantly agitate materials and release fine particles into the surrounding space. Moving further down the production line, the mechanical forces only increase. During tablet compression and powder packaging, machines exert intense pressure on dry materials, which can force high-velocity particle escapes directly into the working environment. The danger of these escapes lies in their delayed effects, illustrated by the lung diagram here in the middle left. By the time a worker actually feels symptoms from inhaling these particles, the damage to their lung tissue is often already severe and difficult to reverse. The specific biological threat depends entirely on the material being processed. Inert dust, like lactose, causes physical irritation. Active pharmaceutical ingredients introduce systemic toxicity. Plant-based organic dusts can trigger hypersensitivity or asthma, while metallic catalysts can cause permanent lung scarring over years of exposure. Failing to map the exact chemical source at your station to its specific biological consequence leaves workers blind to the risk. This oversight is a direct path to terminal lung diseases like COPD and silicosis. If we look at the central figure in this diagram, you see a worker in a full protective suit, respirator, and goggles. When asked how to neutralize dust hazards, novices almost instinctively point to this exact gear. Let's test that assumption. If a powder leak suddenly occurs during a high-speed tablet compression run, what should be your very first line of defense against inhaling that active ingredient? It shouldn't be the mask on your face. As shown in the top right panel, your true primary defense is engineering controls. These systems are designed to physically isolate the hazard and remove it from the air before it ever has a chance to reach the worker. The mechanics rely on precision airflow. Local exhaust ventilation generates a constant vacuum near the source, while closed transfer systems ensure that powders move between machines entirely sealed off from the ambient room air. These physical barriers are then enforced by administrative controls, shown in the bottom left. Strict standard operating procedures dictate exactly how materials are handled, while continuous air quality testing ensures the engineering systems are actually doing their job. That means personal protective equipment, like N95 respirators or P3 masks, acts strictly as a final failsafe. If your facility's engineering and administrative systems fail, a mask alone is completely inadequate to protect you from long-term exposure. We can see how this hierarchy functions in practice with this schematic of a tablet press. During a high-speed run, intense mechanical force causes red airborne power particles to escape the compression zone, shooting outward into the surrounding room. Instantly, the local exhaust system engages. It generates a targeted vacuum force that overpowers the escaping powder, capturing the red particles and pulling them securely into a designated HEPA filtration chamber. Because the exhaust captures the material at the source, the ambient air in the wider cleanroom remains completely clear. The worker breathing the room air stays safe, and the sterile environment prevents any cross-contamination with other batches. This illustrates that effective dust control is never a single action. It is an integrated ecosystem. Equipment, operating procedures, and protective gear must function as a coordinated three-tiered defense shield. Mastering your facility's safety systems means actively maintaining all three of these tiers. By rigorously following good manufacturing practices and preventive maintenance schedules, you guarantee the purity of your product while protecting the human lives on the production floor.